Good day, everyone. Today, I'll be presenting an overview of regular grammar, a fundamental concept in computer science that plays a key role in language processing, pattern recognition, and automata theory. Our topics will be definition of regular grammar. Key components would be terminals, non-terminals, production rules, the right and left linear grammars, and the applications of lexical analysis, pattern matching, and finite automata. Now, what is regular grammar? A regular grammar is a set of rules or productions that describe how to generate strings in a regular language. It is one of the simplest types of grammar in the Chomsky hierarchy and is closely related to finite automata and regular expressions. Now, let's describe about the terminal symbols. Terminal symbols are the basic building blocks of the language. They represent the actual characters or tokens that appear in the strings generated by the grammar. They cannot be replaced or rewritten further. They form the output or the final strings of the language. Example: in a grammar with terminals A and B are terminal symbols because they appear directly in the strings. Think of terminals as the alphabet of the language, and there will be a diagram shown below. Non-terminal symbols. These are the placeholders or variables used to define the structure of the grammar. They help generate strings by being replaced according to the production rules. They do not appear in the final output. They represent intermediate steps in the generation process. In a grammar that is shown in the diagram below, S, A, and B might be non-terminal symbols. They are replaced step by step until only terminal symbols remain. Now, the production rules. It is defined how non-terminal symbols can be replaced with a combination of terminal and or non-terminal symbols. The structure will be a production rule has the form A to A terminal where A is a single non-terminal symbol and terminal A is a string of terminal. Regular grammars can be classified into two types based on the position of the non-terminal symbols in their production rules. In the right linear grammar, the non-terminal appears on the right-hand side of the production rule. Rules are of the form A to AB or A to A, where A and B are non-terminals and A is a terminal. The non-terminal B is always to the right of the terminal A. Strings are built from left to right. It directly corresponds to deterministic finite automata. While the left linear grammar is the non-terminal appears on the left-hand side of the production rule. Rules are of the form A to BA or A to A, where A and B are non-terminals and A is a terminal. The non-terminal B is always to the left of the terminal A. Strings are built from right to left. It can be described the same languages as right linear grammars, but they are less common because they correspond to non-deterministic finite automata. Example of regular grammar. The grammar is shown in a diagram where S, A, B are non-terminals while the A and B are terminals and it starts with the symbol S. The rules is A is to A and A is to B and B is to final state B. the application of regular grammar, and lexical analysis, pattern matching, and finite automata. Regular grammars are closely related to these concepts because they define regular languages, which are foundational in computer science for recognizing patterns and structure. Now, let's break down each concept. Lexical analysis, the process of breaking a source code into smaller meaningful components called token. It describes the patterns that token must match. Example is the keywords, identifiers, numbers, and operators. Each token type like int or 1, 2, 3, and x. It is defined using a regular expression which can be derived from a regular grammar. Regular grammars ensure tokens are defined systematically, enabling efficient parsing during compilation. Pattern matching, the process of searching for and identifying sequences of symbols, such as strings, that would match a specific pattern. Role of regular grammar, form the foundation of regular expressions which are widely used in tools like text editors, search engines, and programming languages. These patterns described by regular grammars can match words starting with a certain letter, phone numbers, email address, and many more. Finite automata, a theoretical model of computation that accepts regular languages, that consists of states that represents the grammar's non-terminals, the transition representing grammar rules, an initial state, and one or more final states. Connection to regular grammar is regular grammars can be directly converted into finite automata, like the right linear grammars in deterministic finite automata and the left linear grammars in non-deterministic finite automata. To summarize our topic, regular grammar is a simple yet powerful tool for defining languages. It provides the foundation for many computational processes like lexical analysis and automata. It defines regular languages using simple rules, which and with the key components terminals, non-terminals, production rules, with the applications on tokenization, pattern matching, and automata. And that's all for our topic of regular grammar. Thank you for watching. Bye bye.